So finally, we come to the keynote speaker. It's Dr. Matthew Andersen from US Geological Survey in the United States. Matthew would have been with us, unfortunately, because of some government budget issues. I guess people who work for the agencies are not able to travel, so we miss his presence here. He already introduced himself, but we have provided a short description of everyone's bios, so you might want to take a look at those. Matthew, you can also introduce yourself again if you wish, but we look forward to your talk.
It's a great pleasure to be with you virtually. Thank you very much to Sarush and Sherry in particular for facilitating my virtual presence. I'm very sad to not be with you in person, but I hope you will be able to indulge a remote presentation. There's lots of expertise in the room. I hope that a little bit of what I say today is new or interesting or helps you put some things together. I've been given the assignment of talking about history, geography, and socioeconomics in the Mekong River Delta. Got some great contributions from my good colleague, Dr. Chi, for this. This could easily be 1 or 2 semesters worth of material in college classes. So as you imagine, we've had to shorten it and hope to hit some highlights that are useful and interesting to you. Next slide, please. I would like to go way back and set the geologic picture, talk a little bit about how the Earth has moved to create the physical environment that we're in today. Some extremely interesting hydrology, as many of you know, and how the monsoons have developed here to create a very rich environment. One of the civilizations that was able to take advantage of this rich environment was the Angkor civilization, the Khmer civilization in what we call Cambodia today. I think there are some really interesting lessons for us to think about in how the Angkor civilization rose and fell. So I'll talk a little bit about that. And then we want to make time for talking about some of the modern challenges to this very interesting system. Next slide. So over 70 million years ago, what we think of as India broke off from Africa and traveled across the Indian Ocean, crashing into the Eurasian plate or tectonic plate about 50 million years ago. And that force of the India crashing into Eurasia and subsuming or going underneath the Eurasian plate causes the uplift that we see as the Himalayan mountains today. This sublimation, the India going under the Eurasian plate and raising up the Himalayas continues today. Next slide. If you're in my part of the world near the Chesapeake Bay, you might be familiar with Smith Island cake. And I think frosting a cake is a very useful way to think about this orogeny or uplift of the mountains. If you're pushing frosting across the top of a cake with a knife, you will see the frosting pile up in front of the knife. That's the Himalayas. But off the end of the knife, where the knife is not pushing, the frosting will trail behind, and that creates or helps us think about the mountains of Southeast Asia that we observe today. Next slide. Here's a much more scientific way to think about this. These are GPS readings. On the left, you see the India plate pushing northward under the Tibetan plateau. Those red and pink arrows moving in a northward direction are the uplift of the Himalayas. But what I'm talking about, the trailing end of the knife, the frosting that's not being pushed by the knife, are those blue arrows to the right that are pushing to the south and west. Those are the forces that create the mountains of Southeast Asia that I want to talk about today. Next slide. This uplift and causes many mountain ranges with river valleys in between. Most of the great rivers of Asia form on the Tibetan plateau, flowing to the west and south and east, including the Mekong River, where we find ourselves today. Next slide. So on the left is a picture of the modern Mekong River basin. About 18% of the basin is in China, where it's known as the Lansang River. A little tiny portion of the basin is in Myanmar or Burma, about 2%. But most of the river basin is in the lower four countries, the lower four Mekong River nations, Laos, Thailand, Cambodia, and Vietnam. In the center map, you see some perspective for the continental scale elevations, where those brown and green colors show the higher elevations, and the blue colors are the lowest elevations. You can see we're in the low elevation area. And then move over to your right, that emphasizes this very low elevation of Thailand, Cambodia, and Vietnam, the Vietnamese Mekong Delta. This is actually some of the lowest delta land in the world. The yellow dots that are on the far eastern edge of the map there, these are the Annamite mountain range, or Yae Trong Son in Vietnamese. This is the boundary between Vietnam and Laos. This is the frosting trailing at the edge. This is the far southern extent of the Himalayas. Next slide, please. So the sediments have been washing down from the Tibetan Plateau for millions of years, but only over about the last 10,000 years or so have we really started to fill up the delta with these sediments. And the sediments are of different sizes. The coarse sediments of gravel and rock are filled with water. Those form aquifers, as they do around the world. And also fine sediments or clays come in between those aquifer levels, aquatards they're called, creating this multi-layer, multi-level system that we observe today. In the bottom right picture there, you see a model that shows how there are many layers distributed throughout the delta. In some places, there are 12 of these aquatard layers. Next slide, please. So just like the Banya Lon cake of the Mekong Delta, the sediments form many layers of aquifers and aquatards. Probably only the top one or two aquifers communicate with the Mekong River Delta and its distributaries. Next slide. This very low elevation system has extremely unique hydrology. As the Mekong flows down to Phnom Penh, it breaks off into a couple of different distributaries. One is the one heading towards the north, the Tonle Sap River, that feeds into the Tonle Sap Lake. I wanted to talk to you about how the different monsoons create different flows. And we've got a really nice short video clip on the left. If you can play that video clip, we'll illustrate how the Tonle Sap changes seasonally. Can you play that clip, please? Just click on that picture. Thank you. But you're not hearing it?
Five times the dry season size. Goes from nearly 3,000 square kilometers to cover floodplains stretching from 10,000 to 15,000 square kilometers, depending on the strength of the monsoon. The lake's depth, which is about 1 meter by the end of the dry season, increases to 6 to 9 meters. In October, the monsoon rains are tapering off. The Mekong water levels start dropping. Then water levels in the Tonle Sap River and lake.
The point of the video clip is to show us that in the wet monsoon, the land is so flat that the Tonle Sap flows to the north, filling up the Tonle Sap Great Lake. When in the dry monsoon, the Tonle Sap Lake empties out. The Tonle Sap River actually reverses direction, flowing down into the distributaries of the Mekong that flow in southern Cambodia and into Vietnam. Next slide, please. This reversal, filling up that great basin around the Tonle Sap Great Lake, has for many thousands of years created a very dependable water source. There are lots of carbohydrates and protein available here, including even fish in the trees that are represented in bas-relief carvings at Angkor and at the Bayan temple. Next slide, please. I think we're all familiar with how you can cut a tree or core a tree and show the age of the tree. And of course, whether we see thin rings or fat rings in a tree allows us to do some climate reconstruction using tree rings. Next slide. So it turns out there's a wonderful witness tree in Vietnam, the Fujian cypress. Phocienia is a monotypic genus that grows to be quite large, very slowly, but grows to over 15 meters tall and often 1 meter in diameter, or 1 meter in girth, many meters in diameter. These trees are witnesses to the climate history and allow us to recreate climatic and weather patterns over many hundreds of years. Next slide, please. The core of this tree, called Po Mu in Vietnamese, demonstrates that there was increased rainfall between 900 and 1300 of the Common Era, very warm and wet period with very dependable monsoon cycling. Next slide, please. And it turns out that this period, 900 to 1300 of the Common Era, is very consistent around the world. Climatologists refer to the medieval climate anomaly, or MCA. In Southeast Asia, this resulted in warmer temperatures, really nice, gentle, dependable monsoons with limited dry season droughts, conditions that were very favorable for producing 2 crops of rice per year, very important to human nutrition. After 1300, those weather patterns changed around the world, including in Southeast Asia. Next slide, please. The Khmer people that moved into the area, probably arriving from the West, were able to establish royalty. Khmer kings built up a civilization built on this water and food wealth, this natural bounty, also building hospitals for their people and healing centers, and allowing for spiritual growth for their people. Both Hindu and Buddhist cultures and religions flourished here. Next slide. Resulting in what we today call Angkor. This is still the world's largest religious structure, the Angkor Wat, the pagoda at Angkor. The central tower, modeled after a lotus flower. You can see an Apsara dancer in the bottom left corner holding a closed lotus flower. This temple is still the world's largest religious structure, still visited by many people today, as shown in the next slide, please. The central tower is aligned with the rising sun on the equinox. So again, last month, more than 19,000 people visited Angkor Wat to see the sunrise over the central tower, most of them Cambodian. Next slide. So hydrologic engineering was the basis of this really large and successful civilization. The barre, or reservoir, that you see in the left-hand picture is nearly 1 kilometer wide by more than 3.5 kilometers long. So huge above-ground reservoirs were possible to capture all of this water and deliver it for large-scale agricultural production. On the right, you see one of the moats. This is around Angkor Thom. Actually, the water in these moats compresses the sand and creates very strong foundations for the temple building. Next slide. All of this natural wealth allowed the Khmer kings to build up large populations. Perhaps 1 million people, or nearly 1 million people, were present at the height of the Angkor civilization. That's larger than the city of London at the same time. One of the illustrations of how much power and wealth and strength the Khmer kings had is that they were able to repel continued military advances, most often from the Cham people that came from the east. In this bas-relief carving, you can see Cham sailors and warriors on the left, Khmer warriors on the right. Apparently, if you fell into the water, you got eaten by a crocodile. That's the guy in the middle. But this military strength, I think, illustrates how successful the Khmer kings were in consolidating power, using this natural wealth to buoy up their civilization and their people. Next slide. With the end of the MCA, the monsoons became much more erratic. Obviously, this would have negative impacts on agricultural productivity, and this was the end of the temple building era in the Angkor area. Next slide. So with that multiple impacts, the changes to the climate, reduced agricultural productivity, probably increases in disease in the tropics here. We think of the final negative impact to the Khmer civilization as the invasion by people coming from the west, the Ayutthaya, that occurred in 1431. Now, next slide, please. So there were definitely Khmer people that continued to live in this area, but in a much more dispersed fashion, without the kind of central government, central production, for probably about 400 years. Next slide. Three different countries began to have increased influence in the Mekong Delta, starting around 1700, but definitely into the 18th and 19th centuries. The Chinese established more and more economic trading influence in the southern Delta area. The Vietnamese expanded agricultural production and agricultural organization, vastly expanding the canal systems to deliver for agriculture, often digging canals by hand with hundreds and thousands of people on crews. When the French arrived in the mid-19th century, they expanded the canals even further. And in the 20th century, the French introduced steam-powered dredges that greatly expanded the size and distribution of these canals, expanding the agricultural production of the Delta dramatically. Next slide. And I think most of us are familiar with the horrifying violence and loss of life that occurred in this area in the middle 20th century. World War II, Japan occupied the area. At the end of World War II, there were wars with France and the United States. The Khmer Rouge and their takeover of Cambodia and Civil War caused a great loss of life and violence there, until the establishment of the current Cambodian government in 1991. Next slide. And then, as Kun Busadi mentioned earlier, I'm happy to report that in 1995, the four lower basin nations were able to come together in the Mekong River Agreement and normalize relations and work towards much more peaceful cooperation in this region that continues to this day. That also was the basis for the establishment of the Mekong River Commission. Next slide. So today there are about 32 million people that are supported by all these natural functions. Lots of subsistence agriculture and fishing occurs, as well as more commercial operations. But that richness that the Khmer kings were able to take advantage of continues to this day, where carbohydrates and protein are widely available to large populations. There are increasing demands on those resources. We're going to talk about that in a minute. And I think many observers in the sciences are unhappy with how the natural functions of the system are not always valued. There are more than 25 plans for this region, especially plans by Americans, French, Dutch, Belgian, Australian. There are contributions from Germany and Japan and Korea in the region. Probably isn't we can't say that there's a synthesized view for how to continue to help humans and nature interact. Perhaps that could be one of the goals of the forum. Next slide. So what are those resource uses and environmental changes that cause us concern? There continues to be agriculture and aquaculture production. Aquaculture is especially busy with producing shrimp in the Mekong Delta. Lots of rice production here continues, as well as other kinds of crops. There is a large hydropower development across the basin, particularly main stem dams in China and in Laos produce a lot of hydropower, with the exception of Myanmar or Burma. All of the 5 nations have dams on tributaries to produce hydropower. There's an increasing concern with the amount of groundwater withdrawal that occurs, especially in Vietnam and also in Cambodia. Navigation is a big part of communications and moving of goods and people throughout this basin, as you might imagine, with all of the waterways that we see. One of the important natural resources of the area these days is sand, because so many countries are building rapidly, and sand is a critical component of concrete, especially in Cambodia and Vietnam. There's lots of sand mining that has impacts on the natural system. This year, in 2025, I've become more aware. I think most of the world has become aware and increasingly concerned about mining pollution that is occurring, especially in Myanmar. That the global demand for critical minerals, for rare earth minerals, is making those more and more valuable. And as those are withdrawn in Myanmar, we are seeing some pollution impacts. And then environmental changes that we are observing. The temperatures of this area continue to increase. That has impacts on increasing rainfall. And we are seeing rising sea levels in the coastal areas. Next slide. Those impacts are observed as ground subsidence. The Mekong Delta is one of the most rapidly sinking deltas in the world, largely due to this withdrawal of groundwater. You'll remember in those early slides, I showed you the layers of aquifers and aquatards. As you withdraw too much of that groundwater, the land above it is sinking. For millennia now, the Mekong River has been delivering sediment, and including nutrients bound to the sediments into these rich agricultural areas. As the dams upstream trap sediment, as some of that sediment is removed for sand mining, there is a starvation of sediment and depletion of the natural nutrients that were naturally delivered. With changes in the monsoons, we are seeing some flooding, which can destroy crops. And then obviously, if there is a withdrawal of groundwater in coastal areas, the sea will come in. And so there are problems with saline intrusion into the aquifers. Next slide. Vietnam has worked hard to be self-sufficient in producing food for their people. In the 70s and 80s, in the 20th century, they worked very hard at trying to increase agricultural production in the Mekong Delta, and in 1986 instituted the Doi Mai policy to try to increase a market economy within their social government. That was very successful. And at the end of the 20th and into the 21st century, Vietnam became one of the world's largest rice exporters. In some years, they were the largest exporter. I think today, India is the world's greatest rice exporter, but Vietnam and Thailand, because of this rich natural area that we live in, has been very successful at continuing to raise large amounts of rice. Some of this rice production was due to Vietnamese farmers producing 3 crops of rice per year, and that's having some negative impacts on the environment, especially subsidence. And so the central government passed Resolution 120 in 2017, encouraging farmers to stick to a 2 crops per year cycle to do a better job of living with nature. Next slide. In my agency, we observe that the problems are multidisciplinary. They are pressing. And so we encourage an interdisciplinary approach. We were very fortunate in 2019 to receive some funding from the U.S. Department of State to try to map out groundwater changes that were anticipated over the coming 20 years, especially with changes to climate impacts, but also changes to demand, and map over that the adaptive capacity of the people of the region and their institutions to adapt to those changes, to be able to produce a socioeconomic vulnerability risk map that's shown on the right. We need more data to be more confident in this model, but we think this model on the Cambodia-Vietnam border is a really useful interdisciplinary approach to tackling some of these interdisciplinary problems. Next slide, please. So Dr. Chi and I asked, can population growth and development continue? Can we continue to have adaptive management and sustainable development here? We expect that we need to foster adaptation strategies and growth strategies for the area, and perhaps the forum can contribute to that. Next slide. I'd like to leave you with a quote from Dennis Gabor, who won the Nobel Prize for Physics in '71. He said, "The future cannot be predicted, but futures can be invented." I think that because of all of the human engagement with this part of the world, we have the opportunities to try to invent some of our futures. And I think with so there can be some contributions from the forum this week to contribute to what those futures might look like. Next slide, please. I'm very sad to not be with you, but it looks like you're going to have a great forum. I would be very interested in additional conversations, so please don't hesitate to write to me, to write to Chi. We'd love to continue this conversation going forward. Very grateful for you for indulging this remote presentation. Thank you very much.
Well, thank you, Dr. Andersen. That's fantastic. It was a great introduction, very comprehensive, and we appreciate it.